When given a set of data, the first thing we look at are the measures of central tendency, which is just where we expect to find a typical data value. And remember, those were the mean, the median, and mode. Okay, the second thing we look at are the measures of variation. And the measures of variation help describe how the data varies or how the data is spread out. Okay, now the two different measures are range and standard deviation. Okay, the range is the maximum data value minus the minimum, okay, which is pretty straightforward. The standard deviation is a little more difficult to understand because there's not a straightforward definition of it. But the standard deviation is a measure of how the data spread or the variation within your data set. Okay, there are two different formulas for it. One based on a population and another based on a sample. So if you look at the sample, okay, the sample standard deviation is lowercase s equals the square root of the sum of x minus x bar squared divided by n minus 1. Okay, the population, square root of the sum of x minus mu squared divided by capital N. Now when you see an n, essentially that's just saying the size of, in this case, your population with the capital N, because we're looking at all the data values, and the n minus 1 has a lowercase n, which is just your sample size minus 1. Okay, and we're not going to get into too much detail about why that's n minus 1, but we will later in the course describe it a little bit more. Okay, but right now just think about these are the two formulas to find the sample standard deviation and the population standard deviation. Okay, now the symbol for the population standard deviation is this weird looking Greek symbol called sigma. Okay, so we're going to go through a basic example of finding the sample standard deviation for the following set of data. Okay, so if we're given just 5 data values, 19, 20, 21, 24, and 20. Okay, we're going to go through the sample equation to see how we actually calculate the standard deviation. And then we'll talk about exactly what all of this, all these symbols mean. Okay, so when we go through the formula, we're going to add x minus x bar and then square them. Well, x just means each of your individual data values. So 19, 20, 21, 24, and 20, those are all your x values, your data values. We need to subtract the sample mean from each of those. So we calculate the sample mean of this data set. Okay, and when we do that, you end up with taking 104, that's the sum of the data values, divided by 5, which is 20.8. Okay, so what we do by hand is we make a little table. The first column are your x values, your data values. And notice I put them in order from smallest to largest. You do not have to do that. I just do that because if a value shows up more than once, that row is going to be the same across. Okay, so once we list our data values, I make a column for the sample mean, 20.8. And then we need to subtract them. So looking at the formula, we have to subtract x minus x bar. So when you subtract 19 minus 20.8, you get negative 1.8. And then 20 minus 20.8 is negative 0.8, and so on. Well, after you subtract x minus x bar, you need to square the results. So you need to do negative 1.8 squared, negative 0.8 squared, and so on. Okay, and when you do that, that turns all your data values positive in this row. I said data values, I really mean the results. So when you do negative 1.8 squared, you get positive 3.24. Okay, so now all these data values are, I just said data values again, all those values are positive. Okay, now we're going to add those up, take the sum, and when you add that column up, that sum is 14.8. Now we need to do the square root of that sum divided by n minus 1. Well, remember, n is your sample size, and there are 5 data values. Okay, so we're going to take the square, s equals the square root of 14.8 over 5 minus 1. So that's square root of 14.8 over 5 minus 1. So when you do 14.8 over 4, you get 3.7. And we need to take the square root of it. Okay, so that gives you 1.9235. Okay, now, the question is, well, what is that 1.92 really telling us? Well, when you go back through, when you take x minus x bar, and we get negative 1.8, negative 0.8, and so on, what those values tell you is how far below or above the data value is from the mean. So negative 1.8 means that a data value of 19 is just 1.8 below the mean. A data value of 20 is 0.8 below the mean, and so on. Now, if we want to think about, we're trying to find how spread out the data is, and if you were to think about these as distances, if you were to add these up, negative 1.8, negative 0.8, and so on, if you add those up, you get 0. Well, then we're saying, well, the distance will be 0 from the mean. If you add them up, you get 0. Well, we want to think about an average distance from the mean. When you have negative numbers involved, a silly way that I think about that is when you drive your car, if you turn left out of the driveway compared to turning right, you're still going a positive distance. Okay, so if we think about this in terms of distance, so distance from the mean, we want to make those negatives a positive. Well, the way that the standard deviation does it is it squares those differences. So when you do negative 1.8 squared, you get positive 3.24. Well, now we see that if you're thinking of distance, a distance of 1.8, like turning left out of your driveway, is not the same as 3.24. Okay, so when you square those, it does change those numbers, which is why we end up square rooting at the end. But before we do take the square root, you want to find an average, which kind of means you add these up, add that column up, and then divide by the number of data values. Well, without getting into too much detail, the way the sample standard deviation does it, it doesn't divide by 5 to get an average, it divides by 5 minus 1. Now, there are some explanations out there that are good explanations and easy to follow, but they take a little bit of time to understand. I don't want to waste the time in the video to do that. Just understand that with the hand calculation, you need to do the sample size minus 1 when you find the sample standard deviation. If you had the population, so you knew all of your data values, then you divide by capital N, which is your population size. And you can see if you divide by 5 rather than 5 minus 1, dividing by 5 results in a smaller answer here. So the population standard deviation is going to be smaller than the sample standard deviation. Okay, so one way to think about standard deviation is an average distance from the mean. It is not exactly mathematically what it is, but I just think it's a good way to think about it. The standard deviation as an average distance that a data value lies from the mean. So in this case, we're saying that a data value lies on average about 1.9 from the mean. Okay, a term that is associated with standard deviation is something called variance. It's not a term or a concept that we use too much in this elementary statistics class, but all the variance is, it's the square of the standard deviation. Okay, so essentially, the number inside the square root is the variance. Okay, and this is used more extensively in more advanced statistics classes. The symbols for the sample variance will be s squared, and for population variance, it'd be sigma squared. because all that it is the square of the standard deviation. Okay, now as far as finding standard deviation by hand, we just did that up here. Now we're going to use the calculator. And the good news is we'll essentially be able to use our calculator to find standard deviation, because you can see doing this table with when there's several values in there, it can be very tedious and time consuming. Okay, so I want you to understand where the value is coming from for standard deviation, but as far as actually calculating it, we will use our calculator. Okay, so to do that, now I have a TI 83 Plus. The steps are very similar no matter which TI calculator you have, but the screens may look a little bit different depending on your operating system. You press the stat key, okay, which is next to the arrows. I'm pointing at it. Okay, and then you press enter to edit a list. Now I already have the values in there. Okay, in L1, meaning list 1, you're going to enter 19, press enter, then 20, enter, and so on. So you list all your data values in list 1, and then go over to stat, and now we want to calculate 1 var stats. 1 var stats means one variable. The only variable we have here are these data values. Okay, now I think they represent ages of students in a class, so that is the only variable we have, is the age of the students, or these data values. Okay, so press 1 var stats. Now your operating system may say xlist and freq, F-R-E-Q for frequency. If that's the case, the directions will be similar. I want to do one variable statistics on list 1, because that's where I entered my data. So notice above the number 1 on the calculator. Okay, notice it says L1 above it. Above 2 says L2. Above 3 says L3, and so on. So I want to find one variable statistics on list 1. So I'm going to do second 1 to get L1 to show up. Okay, then when I press enter, okay, a bunch of values show up. On a different operating system, again, you may have to put xlist as list 1 and your frequency, F-R-E-Q, either leave that blank, so delete whatever's in there, or put a 1 in there, and either one should work depending on your operating system. Okay, but either way, you should get these data values, or these values on your calculator screen. Okay, so X bar, that's your sample mean. Okay, and I'll point out that your calculator does not know when you enter a list whether it's a sample or a population. So it's going to give you X bar every time. You need to know if you put a population in, that should be the symbol mu equals 20.8. Okay, if that was a population. Okay, and then it gives you a few things we don't care too much about, the sum of x and the sum of x squared. And then we have sample standard deviation. Okay, so S subscript x. So that's the sample standard deviation, 1.9235. And notice that's the same thing we found by hand. And then it gives you sigma sub x, which is the population standard deviation. And that's 1.72. And remember, the only difference in those would be dividing by 5 instead of 4. And I mentioned before that when you divide by a larger number, your answer will get smaller. Okay, so you notice the population standard deviation is a little smaller than the sample standard deviation. Okay, and I will mention that if you do scroll down, it gives you other statistics here. N equals 5, that's your number of values in your data set. It gives you the minimum x, the first and third quartiles, okay, which we'll talk about later on, and then MED is the median. So that's a measure of central tendency. So one way to find that, if you have especially when you have a larger list of data, you can enter those in your calculator, and your calculator will find the median. And the good news is, you don't even have to put them in order in your list. Okay, your calculator will calculate it correctly either way. Okay, so that's standard deviation by hand and the calculator. And again, the good news is I'm not going to ask you to calculate it by hand, but I want you to understand where the answer for standard deviation or that number is coming from. And again, think about standard deviation as an average distance that a data value lies from the mean.